Hello, this is Tony Villano with a GED Science video. I'm looking at the GED.com website and I ran across this one about carbon 14. This always excites a scientist to talk about this type of thing. As we all know, all living things are made of carbon, and there's a few different kinds of carbon. There's isotopes of carbon. Carbon 14 is a radioactive isotope. So as years go by, it starts to decay away. So if something is dead for thousands of years, this carbon 14 is going to decay, and there's going to be less carbon 14 in the decaying organism or the fossil or whatever it is. So we could look at a tree. This example is about a tree. And if it's gone for thousands of years, we can figure out how much carbon 14 is still in the decaying tree, and then we can figure out how old it is. That is called carbon dating. And we do that with the radioactive isotope, comparing it to the carbon-12. Well, another way to date a tree, just how old it is to measure the number of rings it has. So if you chop a tree through the middle, you can count the rings. Those are annual rings, and if we count them, we can tell how many years. The reason this happens is because of the growing season and then the dry season, and then we get these rings forming inside the tree. So we can compare those, and they should be the same. And we have a little graph here, but as we can see, this is a comparison of those two things. So these dots compares the age of a tree with carbon-14 dating versus the age of the tree with tree rings. And if they came out exactly the same each time, they should be right in the line. So these trees that are less than a couple thousand years, they're matching up pretty good, these dating techniques. But as we get older, they don't match up as well anymore. It looks like the carbon-14 dating is coming in a little low compared to what it should, and be on the red line here if it was exactly the same. Let's look at the question and see what they want to know. While the two age measurements agree for the most recent years, yeah, all the dots are compared. Yep, right in the line. That's where they should be. They often do not agree for samples dating more than 3,000 years. Scientists attribute most of this deviation to changes in carbon-14 production caused by changes in Earth's magnetic field. All right, that's interesting. Which statement correctly analyzes this observed deviation? Let's read them and try to understand what's going on. Radiometric carbon-14 ages are too low. Yes, they are. These dots, if we look at them, carbon-14 is going up, 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 and these dots are coming in lower than the line, so there's less carbon-14. So, yes, they are coming in lower. Carbon-14 ages are coming in low, so it's either going to be A or C, coming in low. You can tell what it's going to be because I already have it clicked. Let's look at why this one's not right. If the carbon-14 ages come in too low, this implies there's less carbon-14 present. Well, if there's less carbon-14, that would indicate an older organism. And if there's more carbon-14 present, that's a younger organism, because we lose carbon-14 as something gets old. So since these dots are younger ages here below the line, that would tend to indicate that that it's implying that there's more carbon-14 present because they're coming in with a younger age. So it's kind of like almost the opposite of what you'd think. More carbon-14 is younger, less carbon-14 would be less carbon-14 would be older. More carbon-14 would be younger. So, as radiometric carbon-14 ages are low, too low. That's what we have here. They're too low. They're below this line. That implies that there's more carbon-14 present. That implies a younger organism. So what you got to do is walk through these slowly. You just got to think them through. Do your best. Make sure you skip down to the question here and read that before you read this whole big thing up here, because you get confused that way. Try to figure out what the graph is saying. This last bit right here, explain the graph, and you always got to know what's going on in the graph. So just try to read carefully, try to understand the graph, try to understand the question, eliminate answers you know can't be right, and then make your best choice. Good luck on that test. Hoping the best for you.